Good afternoon, YouTube. So I'm working on putting together my 24 volt DC power setup here. So this is kind of my distribution panel. The way this will be set up, this is going into the garage attic, and I'll have 24 volt DC from my battery bank coming in here. So this will be the power meter that will monitor all of the 24 volt DC power and also record kilowatt hours. So everything that comes into the garage will go through this meter. And let me show you how I have this hooked up. It took me a while to figure out the wiring on this. So this is one of these PZEM-051 DC power meters. So it's got the 4 displays: volts, amps, watts, and kilowatt hours. And it uses a 100 amp current shunt here. And it took me quite a while to figure out how to put it into this case. So this was a 3D printed case that I downloaded. I'll put a link to it. It's actually a really nice case. It has the recessed bolt holes for the shunt. So the shunt just bolts right in there. I wanted to make it input and output on the other side, so the power just went straight through. So I have these clamps here. These are like screw clamps, and I just had to drill out the hole in the end to fit over the current shunt bolt. And then I had to notch a bit of a hole here in the side of the case to get these things out. And then you just put your wire in and then tighten down the set screw. So that's the negative. Yeah, for the positive then, what I did was I took I think this is an 8 gauge solid copper wire here. It was bare wire, so I put a piece of red heat shrink over it and then crimped it onto a couple of ring terminals and then bent those up and then held it under this stud here. So this is the incoming positive, and then this is the outgoing positive. So the minus comes off of here, the shunt comes off of these two terminals, and then the positive voltage for the meter comes off there. So yeah, I'm going to have the meter there, and I'm just trying to get everything laid out here on this piece of wood. The plus 24 and ground will come in here. Then it'll go out here into a fuse block. So this will be my 24 volt fuse block. And out of here, I'm going to run a 24 to 12 volt buck converter. So this is rated at 30 amps. I doubt it's actually capable of that, but I only need maybe 15 or 20 amps. So I'm only going to be running this roughly half power. That'll come off of here. And then I'm also going to run my DC freezer off of here. I'll probably come off down here on the bottom. This is my DC power board here, if you will. Right over here is an electrical box that passes through the wall into the attic. 12 volt cables there, that's the red and black wire, go into this fuse block right now and run lights and whatnot here out in the garage. And then right next to it I've got 2 more holes, and I'll be putting a couple of brass screws through there. So on the back side I'll hook up to my 10 gauge cable that's coming from the battery bank, and then I'll run these 2 wires right here, red and black, into the input side of my power meter. And then the output side will run over to this fuse block here, and I'll run the freezer is hooked up there. That's a heavy black wire, runs over to the freezer sockets, and then I've got another fuse running up here to a step down converter, steps down to 12 volt 30 amps, and then I'll power that fuse block off of the 30 amp output. So I'll disconnect my existing 12 volt connections there. I think I'll leave those there. I just won't connect to them. I'll just put some insulators or something over those 2 posts. So that's like my backup power. If this thing fails you know, until I get a replacement, I can just hook back to the 12 volt over there. And yeah, that should get me going here. So yeah, everything's kind of tight here. This is under a shelf. It is protected, so nothing can fall on this. So I'll be able to run all the lights out here. And then also I've got some lighter sockets that I use when we test headlight wiring harnesses. So I need to plug those into a 12 volt lighter socket for power. And yeah, so anyway, we got the board up there, and I got some extra room if I need to add anything later. And I had that piece of wood was exactly the right size to fit in there. I didn't even have to cut it. So it was just a scrap of OSB that I had. Threw a coat of shellac on there, and that'll be my power board. I left a lot of room on the board here, so I have a lot of extra room if I need to add fans and temperature controllers and whatever to put over here. So yeah, I just thought I'd show you my setup here. So yeah, that'll be the next project once I get the chest freezer emptied out. I'll wheel it into the garage, and then I can run the wire from the batteries over here, and then I can liven up this fuse block here, and then that should send power over to the sockets on the wall, and I can plug the freezer in, and it'll be ready to go. Yeah, I'll have an off-grid DC chest freezer that'll just run. All it needs is some sort of solar charge controller to keep the batteries charged, and it'll just run off of the battery bank. Doesn't need an inverter. So yeah, if you have any questions about that, post up in the comments section below. And as always, thanks for watching.